Hey everybody, Mrs. Bianchi. We're looking at, I think this is question 8. Mr. Pinello has 80 colored pencils and 64 markers to divide into containers for his class. He wants each container to have the same number of items. What is the greatest number of containers Mr. Pinello can make if he wants each container to have the same number of colored pencils and the same number of markers? Show your work. So you're going to put that on your piece of paper. Now, whenever you see a complex problem like this, it's a good idea to make sure you identify all the labels that they have. So I see the word containers, I see the word colored pencils, I see markers, and I see the word items. Now, the other thing that you should look for, do we have the words greatest number of, and do we have the same number of in the problem? And the answer to that question is yes, we have both of those words. So usually when you see both of those things, then you know we're probably going to be dealing with the GCF, or the greatest common factor. So if we're going to find the greatest common factor, sometimes in addition to finding the GCF, sometimes it's a good idea to look at the possibility of the need to use distributive property, because sometimes we're multiplying that GCF by some stuff. And in this case, we're going to have containers, right? Now, when we think about the GCF, it's something per something. So is it items per container? Would that be what it is? Items per container? And are we going to have a bunch of these that have only colored pencils? And are we going to have a bunch of these that only have markers in it? So that's pretty much what's going on, right? Now, what would be when we're answering this question, we have to ask ourselves, which number do they need? Do they want this number, the items per container? Do they want how many colored pencils? Do they want how many markers? What exactly are we looking for? Because remember, this word containers, that would be containers of colored pencils if we needed that. And this would be containers of markers if we needed that. So we do need to find the GCF of 80 and 64. Let's write those numbers down. 80 and 64. Now what we want to do is we want to try to speculate what the GCF might be, and maybe even look at some of the answer choices for ideas. Because like 4 would go into both of these probably, right? What about 16? Would 16 go into both of these? And if you have no idea, then just pick a number that you know to go into both. So how about the number 8? We know 8 goes into both because that's mental math. All right, but what are the other values? Over here, this would be a 10. Over here, this would be an 8. So both of these show composite numbers, so we should keep branching. So over here, let's do a 2 times 4. And over here, let's do a 2 times 5. And we're not done with the tree yet because we still have composite numbers. This is composite, so we have to keep branching. So that's going to be a 2 times 2. And then we'll bring the 2 down. Let's bring the 2 down. And let's bring the 5 down. All of this needs to go on your piece of paper, by the way. All right, so let's separate out the workspace for this one because this is not done either. Here we can do a 2 times 4, which means that this would also be a 2 times 4. And we'll keep branching. Here we have a 2 times 2. Bring down the 2. And 2 times 2. All right, so now when we're doing our Venn diagram, we have a couple options for how we can do this. So one method is we can take, I'm going to take a screenshot of the prime factorization that I have here. And I'm just going to move it down here. And then I'm going to do the same thing with this. I'm going to take a screenshot of my prime factorization. And I'm going to move it down here. And we're going to look for our matches. So our matches are matching 2s, matching 2s, matching 2s, matching 2s, and that's it, right? Because this is a 5 and this is a 2, and that kind of got cut off, but that's supposed to be a 2. So we have 2 times 2 times 2 times 2 is what we need to multiply to get the GCF. Now, if we had done one of those Venn diagrams, then let's take a look at how we would come up with the same thing. If we did the Venn diagram, we would have our circle here and we'd have our circle here. One of the circles would represent the first number, which is 80. The other circle would represent the number 64. And what we would have done is it would have been the same idea. We would have circled our matches, and each time we have a match, we would write it in this part. So that's one match. Here's another match. We would have written that down in here. We have more matches, right? This is a match. This is a match. We would have written it down. And then we have still more matches. This is a match, and this is a match. And we would have written it down. And we would have multiplied all of these together, the 2 times 2 times 2 times 2, which is the same thing we have here. So if we kind of chunk this up, this is 4 and this is 4, and 4 times 4 would be equal to 16. So the GCF is 16. All right, so I'm just going to put that on the line here. All right, so now we have to ask ourselves, do we need these other numbers? Do we need to figure out 16 times what is going to give us 80? Do we need to figure out 16 times what is going to give us 64? Let's reread the question to find out if we need that. So find the question mark and let's look at the stuff that's in front of it. So it says, what is the greatest number of containers Mr. Pinello can make if he wants each container to have the same number of colored pencils and the same number of markers? So is that this number? Do we need to know how many items per container, or do we need to know some other number? So take it from there. If you do feel that we need to distribute, just remember you want to figure out 16 times what is going to be the 80 colored pencils. 16 times what would be the 64 markers, if you feel that there's a need to distribute this to get the answer. All right, but read it super carefully. All right, good luck finishing this up.